Hi everyone, this is Thiagarajan, retired Deputy Chief Engineer from Indian Railways. So in this video, I would like to discuss something about the maintenance of long welded rail. Okay, in the previous videos, I have discussed about the principles of functioning of the long welded rail and also the permitted location for laying long welded rail. Okay, these things we have seen. And those who have watched my videos, the previous videos, would have understood how complex is LWR. Because as far as LWR is concerned, the temperature is playing important role. The temperature variation is playing important role. So because of the temperature variation, there will be setting up of internal force in the rail. When temperature is increasing trend, so there will be setting up of compressive force. When the temperature goes to the T maximum, there will be high compressive force will be there in the rail. At the same time, when temperature is in a falling, the decreasing trend, when there will be setting up of tensile stress in the rail. And in the extreme case, if the temperature goes to T minimum, there will be setting up of high tensile stress or force, okay, in the rail. So that is why, so we must be very careful in the temperature variation as far as LWR is concerned. For example, suppose when we are disturbing the track, when you are opening a track, removing the ballast for a longer stretch, okay, when the temperature is maximum, T maximum, what will happen? There will be setting up of high compressive force, but whereas there is no ballast, there is an absence of lateral resistance. So that location will be prone for buckling. That is why you should not disturb the track in the high temperature. At the same time, when temperature is in a lower side, decreasing side, and there is a setting up a high tensile force, so our track, there should not be the loose fastening or missing fastening for a longer stretch. When there is a missing fastening or loose fastening for a longer stretch, what will happen in case of any rail fracture? Because of the increase of the free length due to absence of the ballast resistance, the fracture location, there will be a creation of more gap. It is unsafe. Train passing, more gap is there, it is unsafe for passage. Okay. So that is one point. And another way, another situation, sometime, rails we may have some flaw, minor flaw will be there. And weld also may have some minor flaws will be there. And what will happen in case of loose fastening or a longer stretch or missing fastening, there will be a high tensile force in the rail, and that will open up the minor flaw and results to the major rail fracture or weld fracture. It will become unsafe. So that is why we must be very careful in the temperature at on the high compressive side as well as high tensile side. Okay, we must be very. That is why the Indian Railway Permit Manual has given a lot of instruction for carrying out, for touching the track, carrying out any maintenance activities, limiting the temperature. So there has been fixed close to the TD temperature, close to the installation temperature, so that during the temperature range, the setting up of force in the rail will be minimum. So it can be manageable. So like that. At the same time, you see, so long as the track is, LWR track is not touched, it will be okay. But when it is touched, you must be very careful. At the same time, we are supposed to carry out the regular track maintenance and also the special track maintenance. It is inevitable because during the service, traffic condition, the weathering action, there will be disturbance to the track. So often track will run down. So we have to correct the cross level and alignment, as well as we have to carry out all renewal of worn-out fittings and corroded fittings, and also special track maintenance like through rail renewal, through fittings renewal, and also complete track renewal and deep screening of ballast. So all such works have to be carried out. So for that, Indian Railway Permit Manual has stipulated. So how much extent of disturbance we can give to the track, okay, and what are the precautions we are supposed to take during the maintenance activities. So So all those things have been given detail. So now we are going to see one by one. So whatever under Indian Railway Department says in the coming slides. Okay, let's see about the rail temperature limit first for carrying out the regular track maintenance works like tamping. Okay, here you must ensure, whenever you want to take up this work, the range of temperature, existing temperature should be TD plus 10 degree to TD minus 30 degrees centigrade. In the case of normal sleeper, in the case of welded by sleepers, it is slightly relaxed, that is TD plus 15 degrees centigrade to TD minus 30 degrees centigrade. Okay, because of the sleeper, heavier in nature, and also having the more contact area, and it will offer more resistance. This has been slightly relaxed on the upper side, that is TD plus 50 degrees centigrade to TD minus 30 degrees centigrade. But one more instruction I have given. See, when the temperature increase TD plus 20 degrees centigrade, in the case of normal sleepers and widest base sleepers, TD plus 25 degrees centigrade. Okay, during the consolidation period, we have to impose speed restriction of 50 kmph. So the term consolidation has been used here used. That means, so whenever we carry out the tamping operation, okay, so there will be a loss of ballast resistance. Even though the machine is coming and doing some packing, there will be loss of resistance because already it's settled a bit. So for correction of all levels, that is launch level correction or cross level corrections, or for correcting the alignment by slewing the track. So we have to do all correction. While we are doing it, the position of track frame is shifted so that the underneath sleeper there will be voids, but okay, they are packed, squeezed, and ballast is pushed into the gap. But even then, we can't say we will be able to get the complete ballast resistance. It will take some time for building up of full resistance, settlement. So that period of time requires for building up required resistance is called consolidation period. So during that period, the temperature goes up, beyond the limit, and we are supposed to impose speed restriction on the spot. Not only that, we have to post a watchman, stationary watchman, and see that condition of track is okay, the temperature is high. Okay, but in case anything goes wrong, and he has to take action for stopping the train and intimating to higher official of further action. This is to be done. Okay, this is something about the consolidation and imposing the speed restriction in the case of temperature goes beyond the prescribed limit. Okay, that means TD plus 20 degrees centigrade. Okay, this is very, very important point. You have to note it off. And regarding the consolidation, what is consolidation? We have seen previous case consolidation. What is consolidation? Consolidation is just a process of building up a ballast resistance, and whatever loss of resistance took place, that is to be made up. That period is called consolidation. That process is called consolidation. Okay. This is normally in the case of tamping, this they are given the two situations, two ways. One is that 50,000 gross tons of traffic or period of 2 days, whichever is later. So at least 50,000 gross tons, okay, you have to pass. It has to pass. That should have passed, or a period of 2 days, whichever is later. So then only we will be able to get the required ballast resistance. When tamping is done, we have to wait for this 50,000 gross tons or a period of 2 days, whichever is later at least. This much ensure. If that is the case, we will be able to get the required resistance. So before achieving this ballast resistance in this resistance, if the temperature goes beyond the limit of TD plus 20 degrees centigrade, that we have to impose a speed restriction of 50 kmph. Okay, keeping a station watchman at spot for watching, or at least one round of stabilization. Suppose, see, if one round of dynamic track stabilizer when you are passing, but you will be able to achieve the required resistance. So nowadays, normally, whenever we are doing a machine packing, that means along with the tamping machine, this DTS, dynamic track stabilizer, also used to attach and send, so that So after packing, this machine also, this DTS also will follow, so that you will be able to get the required consolidation, okay, and required resistance. This is the way. But sometime due to scarcity of the DTS, so only the packing machine will go on tamping. So in that case, the farmer, this instruction you are supposed to ensure. And coming to the new laid track, in case of CTR we do or deep screening we do, here not like packing. Earlier case only we are not disturbed the packing, only we are just correcting the minimum disturbance, giving minimum disturbance to the track. We are squeezing packing. But here whenever we do complete track renewal and through sleeper renewal and also deep screening, the core under the sleeper will be disturbed. So the complete loss of resistance will take place. So after laying, after even packing, it will take more time for consolidation, settlement to achieve the required ballast resistance. So in this case, normally, there is schedule available, and after the work of CTR or deep screening, how many packing we have to do, and when we have to do each packing. Between two packings, how many days interval must be there. Everything has been scheduled. It is there. We are supposed to follow. Normally, suppose we'll carry out 3 packings. Suppose after the work, initial completion. That means after the complete track renewal work through sleeper work, after even screening, first catch-up packing will be done slightly, and after that the first packing, second packing, third packing will be done. That means second day of work will be first packing and third day will be second packing, like that we used to carry out. That is as per the schedule. But here, when you carry out the 3 packing, we are supposed to carry out at least 2 rounds of packing should be with machine pack. Okay, so we can do 1 packing manually. But nowadays, mostly we'll all 3 packing we used to do only with the tamping machines. Sometimes due to again scarcity of machine, so you will not get. In that case, only 1 packing will be done manually, and 2 packing will be done by the machines. Because whenever we carry out CTR, TSR and all, we will execute through agency, outside agency. So there we will give the provision for packing, manual packing. So 1 round of packing will be done by manual means, and second, third, it's compulsory. You are supposed to do with the machines only. Not only that, this along with the tamping machine, we will pass the dynamic track stabilization also for achieving the ballast resistance. Because this as well as CTR completed work, spot, and deep screening done spot and all, very very critical. It's since we are disturbing the core under the sleeper, complete packing of sleepers, and we have to ensure the complete consolidation has been taken place and complete ballast resistance has been achieved. Okay. Then the previous slides I have discussed about this tamping and oscillation and all, deploying our tamping machine and DGS, dynamic track stabilizer. And some of you would have not seen those machines, how it is working, and how much disturbance to the track we are getting, and how the consolidation we are able to achieve using the dynamic track. You can see now. So here, this is your tamping machine. This is pneumatic type of machine. Actually, at a time, we will back to sleepers. See here. Normally, as with tamping is concerned, for correcting the level and alignment of the flying machine. So, and it is only the it will give only minor disturbance. So wherever there is a loudness needed to lift the track, the alignment action is needed to shift the track. However, because of the position is changed, so there will be some points underneath the sleepers, and that is being back squeezed by the machine. Just give it vibration and the balance of screw and push to the under the sleeper. Good packing. So however, the immediately we cannot achieve the resistance. Full resistance cannot be built up immediately. Okay. something about this machine. So that is why we want to deploy this one, the dynamic track stabilizer. This machine we are deploying. This is we are deploying for achieving our conductor balancing, just consolidations. Actually, this machine, when you are normally we used to attach this dynamic track stabilization machine with the tamping machine, so immediately you are able to get the required resistance, required consolidations. Actually, the principle here is just applying the vertical load. The vertical load, static load, vertical load is just giving at the rate of some around 300 kilometer load is there, and there are some wheels, guiding wheels there that will hold the rail and oscillate the track. It's giving horizontal oscillation. The vertical load, horizontal oscillation. So we are able to get the full consolidation of the track and the ballast. Okay. So that we are able to get the resistance of ballast immediately. Actually, when we are passing this machine, on the track, and one pass we are able to achieve around 1 lakh gross tons of traffic passed, similar to equivalent to that. So actually, as we have discussed, we require 50,000 gross tons passage, 50,000 gross tons of traffic should pass. But here we are able to achieve 1 lakh gross tons of traffic equivalent to that. This is something about the damping and the consolidation using the dynamic track stabilization. Okay, and also when we are doing the correction of level correction or longitudinal level correction we want to do, normally the track will be lifted, but there are some restrictions, because whenever we lift more, the packing slipper will be disturbed. The resistance will be lost a huge amount. That is why the lifting has been restricted. Whenever we want to lift the track, maximum 50 mm we can lift that at a time. So if we want to lift more, because there are more irregularities there, we want to do more lifting, then we have to do only in stages. 50 mm, then complete packing consolidation, then 50 mm, like that. So we have to go only in stages. So at a time we cannot lift more than 50 mm. That is maximum as far as LWS is concerned. Okay, we are supposed to follow that. And also sometime we go for the manual packing. The machine packing always we have to resort only machine packing, tamping. But sometime machine availability will be a problem. In that case, due to the urgency, we can go for manual packing. When you want to do the manual packing, there are some restrictions. We are supposed to follow the restrictions, because at a time we can open only 30 sleeper space. Okay, 30 sleeper space only we have to open, and leaving the 30 sleeper space intact, and we can go to the next 30 sleepers. So like that only we can go to pack. We have to do the manual packing. What is to be done? Only 30 sleeper space we can pack, open, leaving 30 sleeper space intact between the next stretch. Okay, 30 sleeper space, like that. So alternatively, leaving 30 sleeper space we can do it, and the left out portion we can tackle, we can deal only after the consolidation of the portion which was packed early. Okay, that means only after the passage of traffic for 24 hours in case of section where we have 10 GMT. Okay, so traffic, you are used to say traffic density. So the section where we have the traffic density more than 10 GMT, in that case 24 hours we have to wait. After that only we have to tackle the left out portion. But the section having a traffic density less than 10 GMT, in that case we have to wait for 2 days for tackling the left out portion. This is something about it. The manual packing. Okay, here are some restrictions. Okay, since we are disturbing the ballast, packing and the sleepers slightly, and there is a loss of ballast resistance takes place. So we have to wait for building above resistance here also. But sometime in the track the irregularities more for a longer stretch. In that case, we are not able to, we can't correct for fully satisfactorily if we are opening sleepers for 30 sleeper space. In that case, we can go for 100 sleepers case. In this case, JE or SSC PVA must be available spot, and only under his supervision, and he can take up the work up to 100 sleeper he can open. Continuously it can be opened and packed for correcting the irregularities. Okay. In this case, JE or SSC PV must be available at the spot, and of course, and we have to follow the temperature limit and all. Okay. This is something about packing under supervision of JE SSC PV. Manual packing. And casual renewal of sleepers. If you want to do casual renewal sleepers, suppose one sleeper, say, okay, there will be some always, there will be broken insert will be there, and sleeper broken will be there. Casually, we want to renew sleepers, So these are all the instructions. Suppose we want to do sleeper renewal, casual sleepers. One sleeper we can do and leaving 30 sleeper space. Suppose this is one sleeper we are renewing it. Next sleeper also available continuously some after a 5 sleeper like that it is there. But we cannot tackle at a time. So when you want to tackle sleeper, casual renewal sleepers at a time, so one sleeper in 30 sleeper space. So we have to ensure 30 sleeper space intact must be there in between. Suppose the next sleeper also we have some broken sleeper, we want to do it. What we have to do? First renewing this sleeper, after packing completely, we can go for the next sleepers. Like that. This side also we want to tackle that minimum 30 sleeper space must be there. So 1 in 30 sleepers, if 2 or more, renew one, pack, then go to the next. Okay, this is to be followed. And like that, fastening also, even it is also routine work, fastening, there will be some corroded fastening, some missing fastening will be there, and broken fastening clips will be there. All those things, we have to do routine work. In this case also, we want to do it 1 in 15 sleeper. So that work should be supervised by keyman. Only under supervision of keyman only has to be, the work should be taken up, that renewal of fastenings. Here 1 in 50 sleeper space. One fastening we want to renew, next fastening we can do only after leaving a gap of 15 sleeper space like that. So continuously we want to do it like that only. So remove one fastening, 15 sleeper space, keeping the 15 sleeper space in between. Then next sleeper we can tackle. Like that continuously we can do it. But this work to be undertaken under supervision of keyman. Okay. So then suppose sometime we want to renew some rubber pad underneath and all. Further we have to lift the track, lift the rail. So we have to remove some fastenings and all. We have to lift the rail. So or otherwise, okay. This case, the gangmate should supervise. Only under the gangmate only this work has to be undertaken. But here there must be a clear space of 30 sleeper space distance must be ensured in between the 2 sleeper where we want to tackle the fastenings, okay, involving lifting of track. Another thing, suppose in case of, some temperature is low, TD minus 10 degrees centigrade is low, so comfortable. Temperature is low because we are much bothered about the buckling. If the temperature increases, high force will be there. If removing the fastening, chance for the buckling and all. That is why, suppose temperature is below TD, that compressive force we can avoid, and thereby, fastening up to 5 sleeper on either side may be removed for replacement rubber pad. You can open 5 sleeper this side. You can remove the rubber pad. If you want to remove, we can replace it. Crushed rubber pad, we can replace it. Okay. So these are the instructions we are supposed to follow. Okay. Okay, like that. Okay. Why I mean all these things because of there should not be at any cost the loss of resistance. Okay. That is why with the minimum disturbance you have to take up the work to avoid the bad consequences. Okay, this is something about it. And coming to the SCJ is normally SCJ switch expansion joint we are providing at the ends of the LWR CWR for allowing for accommodating the expansion contraction of the welded track. Okay, LWR CWR. So this is the device normally we are providing at the ends of the LWR. It is available, and this arrangement, this is only I am showing the conventional type SCJ. Here will be the stock rail. This will be the tongue rail. Okay, So expansion contraction. Suppose this side is SWR side and this side is LWR side. Okay, connected to the LWR, there will be expansion contract. The tongue rail will move up and down, and there will be a gap available. There should be free expansion. There should not be any obstruction. At the same time, okay, that fittings also should be intact because it is a splice arrangement. And normally Keyman used to patrol, no, daily patrolling. He has to see the condition of the SCG and whether it is okay, packing attendance is okay, and whether bolts are intact and all. So yes, you will tighten up. At the same time, for free expansion contraction, the greasing has to be done. The greasing of SCG, oiling greasing has to be done once in fortnight. Okay, this work will normally be taken up by the keyman. Once in fortnight, he has to plan for greasing of SCGs, and tightening, of course, daily patrol. He has to see tighten the bolts. Okay, and also if the because normally it is a joint, there will be some impact. The packing disturbance will be there. If that packing hidden, then he has to inform the gangmate for giving the attention to the joints. Okay. Okay, coming to that, through fittings renewal. Through fitting means, suppose we in particular such, there will be a lot of corrode clips will be there. At the same time, periodically, and we used to check up the toe load of the clip, toe load of, because as far as elastic fastening is concerned, what we have, rail underneath we have the rubber pad and liner will be there. And clips we are providing, the clip is elastic clip. We used to say Pandro clip, some IRSE clip, elastic rail clip we used to provide. And that is providing a toe load. It is just a spring action, toe load. It is providing some 1000 kg toe load is there. It's around 1000 kg. Toe load will be given. The toe load, if there is a loss of toe load, it will not, the whatever ballast offer resistance, it goes to the sleeper and, goes to the fitting and it will transfer to the right. If the toe load, sufficient toe load is not there, it will be just like a right wheel fastening. It will permit longitudinal movement. So it should be effective. So for that, periodically that will be done. Inspection will be done for checking its toe load condition. If it is there is a loss, then there is a how much loss permitted is there. Otherwise, the entire such, after inspection, there is a loss of toe load. Then such will be planned for through fittings renewal. And corrosion also, more corrosion is also we will plan for through fittings renewal. Not only clips, the crushed, there will be some crushed liner will be there, and crushed rubber pad will be there. All those things, when it is not effectively functioning, and it will not transfer the resistance. We have to plan for, we used to plan for through fittings renewal. So whenever we do through fittings renewal, what is to do? We have to plan. This is because the entire fastening we are removing, So that is why normally we used to plan decessing also. Decessing along with the this one through fitting renewal we have to plan. This is something about it. Okay. Coming to the other type of special interest, we used to have deep screening of ballast. So deep screening of ballast also is very important because initially, we are laying a track with the ballast bed. The clean ballast will be there. There will be sufficient cushion will be there. Okay. Whenever the ballast is new ballast, normally it will provide a very good elastic bedding. After some time, course of time, what will happen because of weathering action and all, the ballast will get caked up. Caked up means full of muck will be there. So the resiliency will not be there. Once resiliency is not there, not act as the elastic medium, the running will not be all right. Okay, running will not be all right. And that is why then we will inspect the condition of the ballast, periodically. If the condition is ballast, we will go for the cleaning of ballast. We will completely screen the ballast and remove the muck and put the clean ballast inside. Okay, that is called the deep screening of ballast. And we used to do two type of gas cleaning. One is shoulder ballast cleaning. Other one is this one, complete deep screening. Okay. Shoulder ballast, only shoulder portion only we used to clean. Okay, we will not touch the core and the sleepers. But deep screening means complete ballast. Even under the core also we will disturb and we will remove the ballast, clean it and put them back. And further, we used to do manual means as well as mechanist means. Okay, so normally manual means only we used to avoid nowadays. Only we will go for only mechanical means using the ballastic cleaning machine. Suppose sometime The large, stretch is more long. Suppose machine will not be available, but due to urgency, that time we will plan for deep screening using manual means. Okay, but well, this is something about the cleaning of ballast. But whenever we want to take up the work, cleaning up ballast, and the work should be taken up with the TD plus 10 degrees centigrade to TD minus 20 degrees. Only within the range only we have to carry out the work, that without cutting or temporary distressing. That means normally when you want to plan deep screening of ballast in a section, we have to take a survey of the prevailing temperature. We used to do the survey for 1 week. We can take the temperature. We have to study how the temperature is there during the whenever we are daytime when we are planning, in daytime or night time. So daytime, so we are planning certain time. During the time, what is the temperature prevailing? So temperature prevalence within the range, our requirement TD plus 10 degree, TD minus 20 degree of this particular section. So we can straight away do the deep screening from one end to the other end. Okay, so we are able to get the required temperature within the range specified. We are safe, so we can carry out the deep screening operation from one end to the other end, deploying the machine, and you can do the cleaning of ballast. But sometime see, already we have planned, but temperature is not comfortable. That means it is high temperature is there. Suppose normally, even though we are postponing, we are not able to get the required. Some sections always there will be high temperature. We are not able to get the required range of temperature, that is between TD plus 10 degrees centigrade to TD minus 20 degrees centigrade. In that case, what we have to do, we have to plan certain. Suppose 1 kilometer we can take. So 1 week we can complete this 1 kilometer. That stretch, what we have to do? That stretch we have to isolate. We have to do temporary distancing. So putting some SAJ, we have to isolate that portion, and we have to do temporary distancing. That means suppose there this temperature is some 40 degrees centigrade distancing temperature, and our limit is TD plus 10 degrees centigrade maximum, let us assume. That means the temperature prevailing is within 40 to 50, okay, no problem. But there is a 60 degrees centigrade prevailing always whenever we are planning, during the time our temperature is 60 centigrade. In that case, see, we cannot carry out because it is exceeding the TD plus 10 degrees centigrade. That is why what we are doing, and we will do temporary distancing. That means 10 degree below the maximum. Suppose 10 degree below max means what? 60 degrees centigrade is there. Minus 10 we can have. So TD we can do that. We can do the temporary distancing at 50 degrees centigrade. Okay, 50 degrees centigrade. When you do the 50 degrees centigrade, even though temperature goes 60 degrees centigrade, there is variation of 10 degree only. So the force will not be there. Compressive force will be only for the variation of 10 degree only. So that is the concept. So whenever we are not able to get a TD range of temperature, required range of temperature, that is TD plus 10 degree to TD minus 10 degree, when it is exceeding the limit. So we have to do temporary distancing 10 degree below the maximum temperature likely to be attained, okay, during the period of work, that it says. That work, in that case, we have to isolate that portion. We want to plan deep screening. That portion should be isolated from the rest of the portion, putting some SEJ and do temporary distancing, complete the one, and we have to go to the next 1 kilometer, like that we can go. So this is the procedure we are supposed to follow that. Okay. So deep screening LW may be done from one end to the other end, okay, like that. So after the deep screening, complete packing, consolidation, there is schedule available, what type of packing, how many type packing you have to do, how the consolidation will be enforced and ensured, all those things. So we are supposed to follow, okay. And finally, distancing LWR has to be done because it is compulsory. Because if it is completely disturbed, because the packing disturbed, sometimes temporary distancing to do. That is why after completion of this deep screening, we have to do one complete distancing overall. Complete distancing has to be undertaken. Okay, and here also whenever we do deep screening, normally we should plan such a way. Machine will be there: deep screening machine, ballast screening machine, then damping machine, then DGS. We should always have this combination. Okay, the entire machine consisting of this one, BCM and tamping machine and leeches. It is normally it is advisable to have that for effective packing and effective consolidation to achieve the building up of resistance to the required level. Okay, this is something about the deep screening of work in LWR. Then in the previous slides, I've discussed about the ballast cleaning, that is deep screening of ballast. Okay, actually, we used to do in two ways. One by manual means, another one by mechanical means. So mechanical means by we used to deploy this machine, ballast cleaning machine. So with the help of these machines, so we are cleaning the ballast. That means we are doing the deep screening of ballast. Here you see, this is a cutter like arrangements. Here just it takes everything, complete ballast under the this one under the sleeper. Okay, just like some cutter chain will be there, and just like a hand will be there. Just cut the ballast, take it will go to the conveyor like that. Just we can. So some of you have not seen BCM working. So for them, just I play the video. Just you can see how it's working, and you see this is this is actually the screened ballast. Just putting back here. Already told this is a cutter arrangements. Here the ballast under the sleeper is cut and it is taken to the conveyor and goes to the screening unit, and there the screening was being done. There are a lot of sieves available there in different sizes, and the cleaned ballast is separated and the muck and dust will be separated. The cleaned ballast is taken back to the the place through conveyor, and it is just dropped down, and the muck and the dust, the separated one, that is taken separately, and they are thrown out. This is just formation. So you can see here, this is a muck and dust separated from, after screening, after sieving on, it's all thrown out. Okay. This is your cutter arrangement. This is a clean ballast is coming here. This is something about the deep cleaning of ballast. Okay. And of course, other special matters you want to carry out now, lowering of track is there sometime, and major rail motor works, removal of large number of sleepers. Here also, because the complete our ballast resistance is disturbed. So in this case, the post should be isolated. We have to carry out. Suppose one bridge is there. That portion we have to remove. That portion should be isolated. Putting the SEJ on both sides. We have to terminate the LWR, and this bridge will be separate. Will not function as LWR. So put some SWB also. So we after this one, completed the work, we can connect and do some researching. Okay, that is to be done. Like the renewal of large number of sleepers, just like the deep screening, renewal of, we can isolate that one. Okay, complete that, and we can connect. You can join that. You can join the LWR. Okay. And major element occurs, slew involved, completely ballast resistance will be out, like lowering of track. So all these things, we have to isolate our this portion of work where we want to carry out the work from the LWR, putting some message on both sides, completing the work, then we can join together. Okay, join together and do some discussing. This is important. This is to be followed. So let's see when the discussing of LWR is to be resorted to. So there are provisions in the Indian Railway Permit Manual, at what circumstances we have to carry out the discussing of LWR. That means differs beyond the limit specified and exceeds the maximum designed cap of FCG, and when stock and tongue rail cross the reference line. Pretty well, and what is discussing? Discussing is a releasing of locked force in the rail. That means when normally, initially, we are laying the rail with sleepers at prescribed range of temperature, TD range of temperatures, that is close to the T-mean always. Why? Because, to balance the compressive force and tensile force, via media we are fixing the range of destressing at range of temperature, and we are doing the destressing at the temperature range. In case of any variation, that will be the compressive force or tensile force setting up will be with reference to the installation temperature. Normally it will be uniform, but in course of time, the installation temperature got disturbed because we undertake various activities in the track. See, sometimes we used to do renewal of fastening and renewal of casting of sleepers, and sometimes we used to renew rails also, some portion in case of any flaw or in case of any fracture, we used to put some cut rail and weld it. Because of these activities, the installation temperature got disturbed. Okay, and because of that, when in case of any variation in temperature, the setting of force in the central portion of the rail, in the LWR will not be uniform. Sometime one location will be less, sometimes it will be high, sometimes it will be exceed in the limit also. That location will be critical, becomes critical. It may result to some buckling or rail fracture. That is why it is a responsibility to check and ensure that our LWR, the force should be uniform throughout the length, and the behavior should be watched. So in case there is any erratic functioning is there, immediately we have to plan for the destressing LWR. So this is the first case, differs beyond the limit specified. So that is why we used to measure the SEJ gaps, because SEJ is the indicator that will indicate the performance of the LWR, whether it is functioning properly or not. Okay, and also Indian Railway Permit Manual provides a theoretical range of gaps for various zones and various rail sections. Okay, and there are the range of gaps what should be available for different temperatures. It has been mentioned, and we are supposed to follow that, because measuring the existing gaps and recording the temperatures or the particular temperature and what should be the gaps available, we will refer with the table. When compared with the existing gaps, whether it falls within the range, okay. When it falls outside the range of gaps, we can decide the LWR is not functioning properly. There is a erratic functioning is there. Okay, that's one. Then secondly, they're exceeding the maximum design gap of SEJ. Okay. Then thirdly, that when stock or tongue rail cross the reference line. Okay, to explain well, we'll go to the this photo showing the conventional type of SEJ. Okay, this is your tongue rail, this is your stock rail, and this is your gap. And we used to have the reference pillar on both sides. We used to stretch the cord, that's called a reference line. With reference to the reference line, we used to measure the gap, that is the A gap and B gap. Okay, still you want to explain, we'll go here. Okay, this is your conventional SEJ drawing. Here we have tongue rail, this is your stock rail. Okay, the yellow one is tongue rail, the peach color, this is your stock rail. This is your stock rail. Suppose this side, now it's connected to the LWR. This side maybe sometime the LWR or maybe connected to some SWR precipitated track. Okay, this is something about it. Okay, so whenever we are doing the initial setting, when we do the destressing operation, initial setting of SEJ will be done. The initial setting how it should be. Okay, this is your tongue rail tip. The tip should coincide with the center of the center bolt of the SEJ chair. Okay, this should be ensured. And after that, normally this SEJ has been designed for, of course, some maybe 120 mm gap, actually conventional type of SEJ. But nowadays we are designing for 80 mm maximum gap, but its conventional type maybe 120 mm. But however, initial setting gap should be 40 mm. This is the tip. First, it should coincide with the center of center bolt, and then we have to keep a gap of 40 mm, adjust the SEJ, and this side, whatever connection you want to do, we can do it. Some welding and all we can do it. So initial gap should be 40 mm. And after that, it should be divided. The gap should be divided into 20 by 20, and we have to mark it here, and we have to extend this reference line to the reference builder and mark it off. This will be the reference line. Okay, at the time of initial laying, you have to mark this one. This is very, very important. With reference to the reference line only, we used to measure the gap. So whatever the gap that means between the tip of the tongue reel and the reference is called A gap. It is denoted as A. And the reference line to the edge of the stock rail, it is denoted as B. This is B gap. Okay. Normally, suppose this is the LWR side. We are measuring the A gap here. The A gap should be compared with the theoretical range of gaps. For example, when you are measuring the A gap, and we have to record the temperature also. For example, the temperature prevailing at the time of recording the measurement is some 45 degree centigrade. And the decreasing temperature of the LWR is 40 degrees centigrade. Then we have to go to the table here. This is a table available in the detailed permit manual and even the registers also. This is for conventional pH sleeper zone 1. Let us assume this is zone 2. Our temperature is 45 degree prevailing temperature at the time of recording the gaps. TD of the particular LWR is 40. That means with reference to TD, our prevailing temperature is 45 degree. That means TD plus 5 degrees centigrade. And this should be the theoretical range of gap. For example, sub 60 kg rail section, 1660 sleeper. So the range should be 15 to 24. But there also they given plus or minus 10 mm over the theoretical range of gaps is permitted. That means we can plus or minus means lower side we can minus it and upper side we can plus. That means 5 to 34 mm. 5 to 34 mm is theoretical range of gaps. Suppose when we are measuring the gaps, that gap is within the range 5 to 34 mm. That means that is okay. The LWR is functioning properly. Suppose when it falls outside the range, for example, here 5 to 34 mm should be there. 5 to 34 mm, the A gap. Suppose A gap is now it just close to the reference line, 0 gap is there. That means it is falling outside the range. That is not functioning properly. We have to plan. At the same time, instead of 34 mm gap, when it is 50 mm gap is there, A gap, there also problem. The functioning is not good. So we have to plan for this disassessing of LWR. Like that, this way also you have to see. Therefore, this stock is also connected to the LWR, another LWR, LWR2. This B gap has to be checked. It should fall within the range of temperature prescribed, adding plus or minus 10 mm. Okay. Otherwise, this side also we have to plan for disassessing operation. Suppose it is attached to the SWR, means simply we have to adjust the gap. Okay. SWR free track, we have to adjust the gap and weld it suitably, putting a cut rail. This is a way. And also, as per the LWR manual, another first the comparing the existing gap with theoretical range gaps, and another second one is when the tongue rail or stock rail crosses the reference line. When it is crossing the reference line, also we can consider it is erratic functioning. Then you have to plan for disassessing. Then another criteria they are given, when the existing gap is more than the designed gap, then we have to plan for disassessing. That means it is erratic fastening. So nowadays all SCJs are designed for a maximum gap of 80 mm, even including the conventional SCJ designed for a maximum gap of 80 mm only. So when the existing gap is when you are recording, when it is more than 80 mm, then so there is erratic fastening, then we have to plan for disassessing. Of course, this other type of SCJs, we have studied, in case of bridges, approaches, forehand approaches, we used to provide, SCJs. In that case, we have seen two types. One is SCJs designed for maximum gap of 190 mm, and another one is designed for maximum gap of 120 mm. The two cases, according to the usage of SCJ, then you have to decide. Okay, but normal, situation, all SCJs, whatever we are providing, it is designed for a maximum gap of 80 mm. So when the gap is recording gap, in the time of recording, the existing gap is more than 80 mm, then considered to be erratic fastening, then we have to plan for disassessing. Okay, this to be taken in mind. Okay, so these are all the different, the three criteria they are given. So these are all circumstances at which we have to carry out the destressing operation. And another criteria, whenever the creep or the central portion, center of the LWR is noticed more than 20 mm, then we have to plan for destressing. That means what is the creep? Creep is the longitudinal movement of the rail. Actually, central portion should be stable. There should not be any movement. In case we notice more than 20 mm, then we have to plan for further. We used to provide some reference to the center of the LWR. At the time of initial laying, we used to transfer the mark to the rail. Okay. At the time of initial laying, there will be zero movement. Zero, because exactly we are marking. In course of time, there will be slight movement. If the movement is more than 20 mm this way or that way, then there is erratic positioning. Then we have to go for planning of destressing of LWR. Then other one is after a special maintenance operation. Normally, already we have discussed, in case of deep screening. After deep screening, because after deep screening, so normally there will be complete core and slippers is disturbed. So we used to do the destressing. Also, whenever we do TRR, TSR. So all the maintenance operation after that, we have to carry out the destressing operation. Then the fourth one is after restoration of the unusual occurrences. Suppose in case of any the buckling of track may take place sometime, so unfortunately, and any unforeseen incident like accident, in this case also the complete track will be disturbed in those cases. So after the restoration of these that unusual occurrence, then we have to plan for destressing of LWR. Then the fifth one is because normally rail fracture will take place in LWR track, and we have the statistic of rail fractures, and when the rail fractures takes place in LWR more than 3 per kilometer, then considered to be the condition of the LWR is not working. Okay, so that is why that time, and whenever the number of failures exceeds 3 per kilometer, we have to plan for the destressing of LWR. So this is conventional type we have seen. This is a drawing. This is a picture of we are not. This is a picture of improved type SCGs. The earlier conventional type, what we have seen, it is a older type. That also the design for maximum of 80 mm nowadays. But that SCG we can provide only the curvature not sharper than 0.5 degree. But as far as the improved SCG is concerned, we can provide up to 2 degree curvature. We can provide. Okay. These two types. This is one of the type. There is a single gap. And here also the same, this thing, because here also when this is stock rail portion, this is tongue rail, this is movement position. Okay, but here only one single gap is there, similar to the conventional type. And whenever we are setting the tongue rail, initial setting should the tip of the tongue rail should be this center of the center bolt. Okay. Center bolt, and after that we have to give a gap of 40 mm, adjust this portion, this stock rail portion, because this is fitted with this thing. This is stock rail, this is tongue rail movement. Okay. Then dividing the gap, middle mark, then we have to extend the mark to the reference pillar. That will be your reference line. Okay, for future measurements. This is okay. Is a single gap arrangements. This is a way we have to this one. And another type, this is double gap arrangements. So this is, we will be having two gaps. The earlier one and all is 80 mm. But another thing I want to get, this is has been designed for a maximum of 65 mm only, because two gaps we are providing, because single gap only, since single gap we are providing maximum designed for 80 mm. But since it is a two gap arrangements, here the maximum gap has been designed for 65 mm only. Okay. This is a two gaps will be available, but maximum gap designed for 65 mm here. This is 65 mm each. Okay, because more gap is normally there will be more impact. Knocking will be there. That is it is distributed. The two locations are reducing the maximum design gap of 60 mm. However, the initial gap, whatever we are providing, it is same. It is 40 mm only here. Here also same thing. Same. This is, let us assume this is a rail fixed one. The two gaps you are providing here on A location A and location B. But let us this is a stung rail. This is a stung rail. This central portion, let us take it is a stock rail. So the stock rail, this is a tongue rail. The tongue rail tip should coincide with the center of the center bolt. Okay, initial setting. Like that, this side also, this is a tongue rail. The tip of the tongue rail should coincide with the center of the center bolt. Okay, then we used to adjust the gap duly providing a 40 mm. This is also 40 mm. So such a way we go to adjust and dividing the gap. Okay. Center and 20 by 20, here also 20 by 20, we are marking that. We are extend the reference mark to the reference pillar, that will be the reference line, and with the reference line, and we used to measure A gap, and this is a B gap. Here also like that, tongue rail side will be A gap, other side will be B gap. So this is something about other type of input SEG. So both input SEG we can lay up to 2 degree curvature. Okay. This is something about it. The how that can be measured and all the details given in the manual. Normally, in case of single gap and double gap, this is a single gap arrangements. This is a gap, B gap. Normally, anything you can both side LW, we can consider anything A gap, B gap like that. Okay. As far as this two type is concerned, when this is normally used to the measure, tongue rails only A gap. Okay, this is A gap. Suppose this is let us assume this is SWP side. This is LWR side. This is A gap only measure. This is A gap measure. We can measure B gap also. It's optional. So this is the way. So we have to measure the gap. We have to compare with the theoretical range gaps and see that it is working properly or not. Okay. Okay, then this is the theoretical range of gaps. As I already told you, this is for the conventional PS sleepers for zone 1, 2. Okay, for all type, 60 kg, 50 kg, and different density for various range of temperature they given zone 1 and 2. And this is for zone 3 and 4. Okay, this is also conventional PS sleepers. Okay. Then this is for the, I already told you that there are one more option. We can provide the SEG at far end of the approach. In this case, this is a range of temperatures. The far end of approach. Okay, this was zone 1, 2. This was zone 3 and 4. Okay, something about it. Then this is for wider base sleepers. Suppose when we have a track, the wider base sleepers, the LWR on wider base sleepers, and this is a theoretical range of gaps for all zones it is there. But of course, we have only 60 kg here. Okay, and this is far end approach, the same similar way. Okay, so these are all the tables available to refer for the theoretical range of gaps, compare with the existing gaps to decide whether the LWR is functioning properly or not, and to decide for carrying out desensing of LWR. Okay, and this is a history slope curve. So based on this only, the whatever table we have seen earlier, so they given range of gaps for different temperatures, that has been framed up based on the history slope curve. Okay, for example, here this is a history slope curve. Suppose when we take that TD plus 10 degrees centigrade, this is a range actually. Okay, TD plus 10 minus 3 plus 4.4. This is not a range actually. This is a expansion contraction. This is expansion. This is contraction. So normally we will arrive at based on the expansion contraction. Already we are given 20 mm gap. Okay, 20 by 20 we are giving 20 mm gap. So with that we are computing our the resultant gap, how much should be. So that has been framed out for various temperature and various zones. Okay. Regarding history slope curve, how it is made and all, I will tell you in the separate video. Okay. Regarding the inspection of SEG and LWR, Indian Railway Permit Manual provides the schedule for inspection of SSCs and JEs. And they are supposed to do by rotation actually. Okay. The periodicity is the 2 coldest and 2 hottest months of the year, they are supposed to inspect once in a fortnight. Okay, that why means you know pretty well the hot months there will be high temperature, high compressive force will be the rail, the chances for the buckling. At the same time, when the temperature is on the lower side, there will be a setting up of tensile force, which will cause the rail failures, weld failures. So the both extremities we should be very careful. That is why the coldest months will be selected as well as the hottest months. That will be fixed by the DN's concern. Okay. So during the period, the inspectors, the SSCs and JEs, they are supposed to inspect the LWR LWR for its performance, and also the SEJ gaps. They used to measure and record. So this inspection they should do once in a fortnight. They have to record in the registers prescribed. Okay, they should take a follow-up action. And also once in 2 months during other months, because out of 12 months, the 4 months, the 2 coldest months and 2 hottest months, and rest of the months, the 8 months, the once in 2 months, they are supposed to inspect the LWR and SEJ gaps. Okay, so these are the inspection schedule given by Indian Department for SSCs and JEs. Okay, so with that I will conclude this video. Okay. Next video we will discuss something about these unusual occurrences like the buckling, this one rail fractures, and hot weather patrolling and cold weather patrolling, and also the as I told you regarding this one desussing of LWR with or without right transfer. So those things we will discuss in the next coming videos. Okay, thanks a lot.